Hello everyone, and welcome to our Dev Talks video. We just start today, it's our first video, and we call it Dev Talk. We will invite here developers from the Waves team, maybe from the community also, and we will talk with them about some development stuff. Today we have Ilya Smagin. He is Ride development team lead. Hello Ilya.
Thank you now. Hello everyone.
Yeah, so today we will talk a lot about development, about code. We will have live coding session. Ilya will show a lot of things about Ride for D apps. As you may know, we had an update. Ilya, what was the number of the version? 0.17 as far as I remember?
Yeah, it's 0.17.0
yeah,
at the moment. Yeah. Gonna be 0.17.1 very soon.
Yeah, and with that release, we introduced Ride for D apps. So It's a very important and very big update of Ride language. So today we will talk a lot about it. We will show a lot of things. So stay tuned. Let's start from the history of Ride. From the beginning, from the first steps of Ride. So what was the main motivation? Not for Ride for D apps. I'm talking about the first version of Ride. So what was the main motivation behind Ride, behind things like smart accounts and smart assets?
Yeah. So initially, Waves platform was designed with pre-hard-coded entities like accounts and tokens, and there was nothing programmable for user there. Like every operation was pre-built in, like issuing a token, transferring a coin, or burning, or any other operations like assets, whatever. They were all pre-built in the platform. But then it was time to move forward and to add some programming capabilities to the blockchain. So we looked at what was the most important back then, and well, it looks like it were mostly multi-sig capabilities that Waves platform needed. I mean, if you look at smart contracts and other platforms, you probably see things like tokens, but we already have them. So the other parts that were not covered at the time were multi-signatures, maybe some token freezes, some other small tunes for the system.
Okay, cool. So the main idea was behind Ride, it was just like cover basic use cases for...
Yeah, not only basic use cases, but like wide spectrum of use cases that is sufficient enough. Okay,
so we introduced like Ride, first version of Ride, like 7 months ago in September, as far as I remember. It was
mainnet was September, yeah. Testnet release was way before, but yeah, mainnet was September.
April or some kind of... Yeah, so we had Ride on mainnet since September, and now we have updated it. So we'll go to Ride for D apps a little bit later. Now let's talk about Ride. So how it works, like Ride version 1, let's call it so. So the first implementation of Ride, how it works. For example, we have an account and we can write some script, right?
Yeah, so the basic idea was to introduce predicates for the account. Yeah. Predicates meaning some function that returns Boolean either true or false, which either allows or denies transaction for the account.
Yeah.
You might see similar things in Bitcoin, whether Bitcoin scripts on UTXO outputs are also predicates. They return true or false. So that's like the way multi-signature is built there. That's the way freezes, like freezes by height and other things are built there. Yeah. So we had two things in mind, like it should be blockchain friendly and it also should be developer friendly.
Before we go further, you say that it's like custom locks, right? What do you mean, right? It's like predicate of account, yeah. It's a custom lock?
Yeah, I think it's a good analogy. So that initially each account can only send a transaction upon providing a valid signature.
Yeah.
But to make it more flexible, this requirement needs to be changed.
Yeah.
So you can change it to another account log. Think of it this way. Initially we required one signature, now you can tune your account so it requires like 2 signatures, so some height or maybe other requirements like data, transactions and informations in org, whatever. Yeah.
Okay, so yeah, we had right on mainnet, so there were some like applications on top of it. There were multi-signatures, freezes. We've seen there in the wild, let's call it so. And what are the main requirements for smart contracts language? Basic requirements.
Yeah, again, as I just said, 2 things like blockchain friendly and developer friendly.
Yeah.
By blockchain friendly, of course, we mean performance and network stability. And by developer friendly, I think it's language, it's type safety and features like this. Well, I guess I could show some examples.
Yeah, sure.
Blockchain friendliness. So, as we say, should be performant and it shouldn't put network stability into risk.
Yeah.
So, to be performant, we shouldn't do operations that are not required. Like, for example, if you want to check multi-signature 2 of 2, and one signature is wrong, incorrect, there is no need to evaluate the second expression. Or you don't need to go out and read some blockchain data, which is a very costly operation for the node. So, and that was one of the aspects. And if you look at our, well, for example, multi-signature example.
Yeah.
Shall we show something? Yeah. Oh, it's there.
Oh, yeah, we have it.
Okay.
Yeah, I think in live also we have
Do
our users. Yeah, they see our code.
Okay.
So yeah.
Yeah. So look, let's build the simplest multi-signature that has requirements of 2 people, Alice and Bob, to provide valid signature. We'll write it so that we have public keys defined. We have 2 booleans defined, like Alice signed is produced by sigverify function that checks the signature. Bob signed is also provided through sigverify thing. But these variables are lazy, meaning that they are not computed unless they are needed to. So when this code gets evaluated, if Alice signed is false, Bob signed variable does not get calculated, but it's still defined. So the language is lazy by design and it fits the performance aspect of the software we're building.
The main idea is that for smart contracts language, we should avoid all not needed computations.
Yeah,
right?
Well, at all costs, I would say, but sometimes we do need to make some calculations that might not be necessary as well. We can do everything.
Of course, yeah. We can't avoid all situations, but at least we can
like,
minimize.
Reasonable, we would like to apply a reasonable set of practices.
Yeah, I see.
Okay, yeah. And the other thing is the infamous Turing completeness, or for our case, non-Turing completeness. Our right language is explicitly non-Turing complete, meaning that we can know upfront whether the script will evaluate successfully and will not put failed transactions. We don't have any failed transactions in Wave network, as we always know upfront whether this transaction will succeed, whether it will reach the cap of performance requirements. Yeah.
So let's go back a little bit. Let's make one step back. So I think before designing right, you tried to understand how other blockchains work. You tried to research somehow. So did you find any interesting solutions in other blockchains? Maybe some I don't know, patterns or some design things you took from another blockchains or not?
Well, I think Bitcoin design system is great. It is it's a very minimal amount of core entities, like one core entity. They're only they don't have separate things like accounts. They don't have separate things like tokens or native tokens like in ETH or whatever. They will have one simple thing, and it's great to move the system forward when you have very small amount of core entities. But if you ask about smart contracts, yeah, of course we looked at other implementations, but most of them were like Turing complete, and this thing is...
That's why I'm asking.
Yeah,
you said that our language is not Turing complete.
Yeah. We explicitly wanted to avoid that. And it's hard to take an existing language and strip it down, so that there aren't any issues with this. An easier thing would be to take a good set of ideas and start from build on that.
Yeah, so build from scratch with good ideas, so on top of good ideas.
I hope these were good ideas.
Yeah, I think so, yeah. Okay, you said there are two main requirements, two main groups of requirements, let's call it so. It should be blockchain friendly and it should be developer friendly. So in terms of blockchain friendly, you said it should have very good performance, right? So what about developers friendly? What can you say about it?
Well, for developer friendliness, there are like standard things in modern software languages, like they should be at least type safe, for example. It's a bad idea when you can do 2 plus XXX and minus, I don't know, nil or whatever. It's a bad idea.
Why? I think it's a very good idea for JavaScript developers. Why not?
Yeah, that's why I don't like blockchains written in JavaScript, although they do exist, and it's a question, why do they exist at all? Like, why do they still work? Anyway, so as you can see, when we try to do something like this, our compiler gives us an exception that, sorry guys, you need to try to sum up something else. So this is like the basic idea of type safety. And then we started to we started with really very, very small thing, just build a multi-signature, and then see how you can extend the system and build it. Please build it extendable. Another thing, when we looked at our domain model, it turned out that we have a lot of transactions. Surprise, surprise, it was like 10?
Now it's about 13.
Now it's about more, I guess. But yeah,
maybe
but at
14,
that time, at that time it was at least 10 transactions. For example, if you want to allow an account to send data to only certain address, let me try some live coding. Let's say that recipient of the account should be Alice, exactly. Alice from public key. Yeah, and of course, this is not enough. We still want our SigVerify thing to work. Let's not dive into this at the moment, but I want to show the other thing. Okay, so we define the recipient we want to have, and we say that we can only send tokens to Alice. But here's the thing, compiler says we're doing something bad, and this comes from the fact that not all transactions have recipient, like data transaction does have recipient.
Let's start from the TX variable. Where is the TX?
Okay.
I think
TX is the transaction we are trying to validate and either allow or deny.
Okay, we have an account, we have a predicate for that account. It's like our script, our smart contract. And that script, it validates all outgoing transactions from that account, right?
Precisely.
Cool. So, and we have TX variable, like, let's try to understand.
Okay, it's a DTO. It's like a data transfer object. It's an object containing fields of the transaction, so we can access it and we can.
So every time when I want to make a transaction, the script evaluates, and the TX variable, it's just like the transaction I'm trying to send right now, right?
Yes. Yes.
Cool. Okay. So
back to our example. For example, if we write code like this, it might work okay with transfer transactions, but for other types of transactions that do not have recipient will get some mess. Or you'll deploy a contract that will fail. Well, you might not even have considered the possibility to send data transactions or whatever. Let's hint you about that. So there is already compilation error here. Let's look at it later. How to fix this? Let's fix it. The thing is that since we have many types of transactions, TX can be one of many existing types. It could be transfer, it could be issue, burn, reburn, whatever. And all of this is encoded into the RIDE API library, meaning that TX is one of these transactions. So this is called union types. Not very common in today's popular languages, but I think it's a very powerful construction. So our TX could be reissue, order, burn transaction, mass transfer, all of these types of transactions, but only transfer transaction has this recipient field.
Yeah.
So let's rewrite it. So we match TX, whether it's transfer transaction. If it's transfer transaction, let's do this. And if it's something else, let's not allow to work on this. Okay, there is something else. Recipient can also be. Look, the compiler is really trying to help us, because the recipient could be not only could be address, but it could be alias as well.
Yeah, we have.
So this is another point where we use union types a lot. So recipient could be either this or that. Let's match it. Let's also match it. Or we can use a function address from recipient. Okay, let's not do it now. Let's say that we match recipient, and if it's address, then this address should be equal to one of aliases. And otherwise, what? Otherwise, it's false. So no sending to
alias, only to address.
Okay, let's write it the other way now. Address from recipient. Okay.
No, you have address for recipient already for alias public key. You need it for transaction recipient.
Transaction recipient. Okay, let's not waste time on this. Let's just
let's move forward. Okay, so pattern matching. That's what we used here, right?
Yeah,
it's like
it's usually called pattern matching. So,
Scala,
but it's not really pattern matching. It's just type matching.
Yeah.
So TX is of type union of other set of types, and you can match the type of the exact variable to one of the existing types, and then work from this.
So things like this, as far as I know, you can find in many languages, programming languages. Like, for example, in Java 12, they released switch expressions, which makes almost same thing.
Yeah,
so
I know C# also did something like this.
So it's just like the easiest way to check types, check maybe even values. Can we check values using pattern matching?
In Java?
No, in RIDE.
No, it's
only
not. It's not real pattern. It's not really a problem to implement this. But for now, we stick with the simplest implementation.
Okay, I see. Okay, so okay, the language should be developer friendly, and it should be blockchain friendly. And you said a lot about required things, let's call it, for blockchain friendliness and for developer friendliness. Let's move a little bit forward. After Smart Accounts release, after a few months later, we had Smart Assets release. So what was the main idea of Smart Assets?
Oh, it was exactly the same. to some extent. So if you talk about accounts, we put predicates on outgoing transactions.
Yeah.
And what if we put predicates on assets? Then we could say that all operations with these assets are validated through this asset script. So this is how we can effectively lock tokens for up until some height, so that they cannot move. Well,
so for example, if we try to send a token, call it smart asset, every time when we do it, smart asset script just runs, it just evaluates, and it returns true or false, and depending on it, transaction is allowed or not.
Yes.
Yeah. Okay.
Right.
What if we have smart account and I'm trying to make a transfer with smart asset from that smart account? What happens in that situation?
Well, it's natural that two scripts are executed. First, you should be allowed to make this outgoing transaction, and then this token script should also validate the transaction. So in this case, this transaction is validated twice, once by account and another by token.
Both scripts just should return true, right?
Yes.
And we also, I think we have to say that smart account and smart asset, for example, their script also returns Boolean value, right? It should be always Boolean, their script's result.
Yeah. So it's either true or false. Well, if the script fails, it's effectively false because transaction doesn't appear anywhere.
Yeah, and there's just like there are three main ways how you can exit the script, right? It's like a return true, return false, and throw.
Yeah.
Okay, so.
Well, throw is like a simple way to stop the execution with an error message to a user. Yeah, we'll see that maybe if we get to write for the apps today, we'll see it.
Yeah. Sure, we'll get to write for the apps. Sure. Okay, so we still have write for smart accounts, write for smart assets. Can we write the apps decentralized? Can we create decentralized applications on top of it?
Well, yeah, indeed we can. But it was a funny moment that closer to release of write, it turned out that in combination with data transactions, we can actually do stateful interactions. And by this, I mean that given your current state formed by data transactions, you can either allow or deny another data transactions which change this state. So this means state machine. And this state machine is stateful computation.
So using
one can even call it Turing complete if you take into consideration the mining loops and cycles of transactions.
So we can say that the right language in first implementation is not Turing complete, but the whole system is Turing complete somehow.
Yes. Well, it's very easily Turing complete, since you can build a state machine and you can have steps in there. It will take time to go through all these steps, but you can perform any calculable computation.
So as far as I remember, there was an article on Medium from you about stateful DApps using contract. Yeah. So maybe you can find it on our blog on Medium. So try to find it. Okay, so you say that it's possible, but is it hard to make the kind of applications?
Well, if you only operate state, it's okay, you can do it.
Yeah.
But if you try to put tokens into the system, it gets much harder. You need to accept payments and update some information which wasn't possible at all. Then you need to make payments and make them atomically with state changes. And since these transactions, transfer transaction and data transactions are different, well, it's really tricky.
So, like there are issues with the themacity of operations, right? It doesn't allow you to to update the state, to at the same time to send some tokens.
Of course, we don't have such type of transaction, and since we cannot issue new transactions, we can only validate existing ones. We didn't have any composite transaction that both puts data and sends tokens. Yeah.
So are there any pitfalls using write like in first implementation?
Yeah, you have to be very careful with this, and probably you'll get into issues with fees and this state synchronization.
Yeah, I see.
And another thing is that, well, not the user, but the contract will have to pay for invocation. You have to keep that in mind, like limit the group of people when use this. So
Yeah,
it was doable,
so
but
easy,
it was like, you know, complex math problem that you like to solve.
Yeah, I see.
Not exactly productive.
I see. Okay, so let's move to write for the apps finally. I think it's the most interesting topic for our dev talks today, so let's move to write for the apps. There was a blog post also about write for the apps roadmap, and you described some main things about it, so I think our dear users and developers can try to find it also in our blog. But for now, let's just cover main requirements also for write for the apps. What do we want to get with write for the apps?
So yeah, first, of course, we wanted to address the problems with previous approach when we only have write and data transactions. And it would be really nice if we could just stick to what we had, but it was really tricky. So the idea was to give a possibility to introduce a possibility to deploy a script and to invoke a script, so that this script actually does something that is encoded.
Yeah.
Of course, operates with tokens that are core entities on the platform. So this is like our motivation at that point.
Oh, I see. So we tried to handle somehow all pitfalls of first implementation of write, right?
Well, again, it's like you try to solve 80% of problems. You don't need to solve 100% of problems.
I think nobody can solve all problems with the smart contracts yet in blockchain. So,
well, maybe it's the scope of blockchain is very narrow, like in your.
Maybe. So, by the way, we didn't talk at all about gas. So many developers of smart contracts, they face with gas, for example, in Ethereum or in our blockchain. So we didn't talk about.
And that's for a reason, you know. we don't have gas, and we don't need gas, and so our computations can be pre-calculated. I mean, their complexity. We can just set a cap and make all transactions flat. It requires flat fee for all transactions.
Sounds very cool. And for example, in you said that in write we in first implementation of write, I will call it write and write for the apps. I think it's clear enough for developers also. So we had write. There is no gas at all. For write for the apps, we also do not have gas, right?
Tell me.
For write for the apps, we also there is no gas.
We also don't have any gas because it's based on write, and it doesn't require gas because all computations can be estimated upfront. So we just estimate the computation. If it fits the blockchain, the nodes accept it. Otherwise, it's declined.
So we still the write for the apps is still non-Turing complete, right?
Yes.
Okay, so we will not have gas. It's just like it just extends the write, the first version of write.
Yes.
Write for the apps just extends.
It doesn't break any concepts actually. It just introduces things like functions. But the thing that everything is an expression, it's still there.
Okay, so let's just go as deep as we can into the code, and let's try to write our first smart contract, at least. Even if you have already written smart contract, we can.
What a coincidence! I just opened something like the app. Let's stick to a small example of what we already have. So otherwise we will sit here for an hour more. Maybe it's too exhausting for Friday. So let's build a small smart contract that works like wallet, so that someone can deposit tokens there. In our case, we'll limit it to waves only.
Yeah.
And then people can withdraw, but everyone can withdraw only his own funds or her own funds.
So it's just like one wallet for a lot of people. We can just send there, deposit there some tokens, it just holds, and we can get it back at any situation. But for sure, we can add some, I don't know, custom logic that you can take it back only after, I don't know, 1,000 blocks.
Yeah, of course.
Yeah, and we will keep it simple for
it's like, example 101.
Yeah,
example 101. Yeah. Okay, so I've this function written, it's called...
Okay, can I ask you, there are 3 lines on top of the function. What is it? There are 3 declarations as far as I
it's
see.
something that we had for a long time, but we didn't use it because it wasn't necessary. But now we have a new type of script, not only expression but DApp.
Yeah.
We are trying to build at the moment, and we also have versioned standard libraries. Version 1, version 2, version 3, the language and the library evolves. Therefore, the standard library evolves and functions are getting added to.
So that's how compiler and IDE try to distinguish write and write for the apps using that declarations, right?
Yes. Yes.
Okay. So let's go to functions.
Okay. Yeah. There is a comment there, and you can try it on your own, by the way.
Yeah.
But
you have to wait for activation on testnet.
Yeah. Since it's not testnet at the moment, I have my own node running, and we'll work with it.
As far as I remember, it should be go on testnet tomorrow.
Yeah, tomorrow,
like
around
at
12, 14
UTC. Yeah, some kind of that. So you can go to dev.pywaves.org and you can check it there at what time it will. Yeah.
Let's see, activation.
It's for testnet, right?
Oh, yeah, testnet activation. It's approved. It should be, around 14 p.m.
Yeah, tomorrow, just like 21 hours left. So tomorrow you will be able to try it on testnet. If you want to try it right now, right today, you can try to run your own custom blockchain. For example, using our Microsoft Azure template, and you can try to do there. So let's go back to our code.
All right. So these are the how do you call it? Directives for the compiler that you use library version 3. You're building the app. It's an account. We'll get to it. So we have a function deposit that accepts payments. And you can access payments through this variable that is bound through this callable annotation. So the idea is like this. When someone invokes a script, script should be able to introspect this invocation. Like, who did this? Who is the caller? Is there any payment attached? Things like this. So this is bound through callable annotation and its variable. So in I you can access payment that will allow you to find out if payment is there and how many tokens or waves is actually attached. So we go like this. If tokens are attached, then sorry, we can only work with waves. This contract can only work with waves at the moment. Then we read our state and try to understand how many tokens this person already has. So we build current key from his address. We query the account state by this key. Yeah.
Let me just note that it's account state, not contract state.
It's account state. I'll explain later.
Yeah.
Okay. For now let's say DApp state.
Yeah, DApp state. Okay.
So we query this DApp state for integer by this key. If the record is there, then that's what we need. Otherwise, it's 0. The user has not yet interacted with the contract. Okay, we got current amount. Now we got we evaluate the new amount we want to record to the blockchain, and we return write set. Right set, it works something like data transaction. You just build a list of data entries that should be recorded to the DApp state.
Okay, so let's get back a little bit. Again, let's make one step back.
Okay.
There's a script type account. So am I right that it's still like usual account? We just can attach there not usual write. We can attach write for dapps, let's call it so. We can attach more complicated, more custom, more custom scripts, let's call it so.
Yeah, for now it will look a bit weird. There's previously we discussed that we can attach predicate to the account. Now we can attach functions, and what do we do with predicate? Let's get back. Let's get to it in a few minutes.
So there are no new core entities. We just like extend smart account.
We don't introduce any core entities. There is no like separate DApp thing on a blockchain. It's like
usual account.
Yeah, it's just tokens, transactions, and accounts.
Yeah, I see.
Some accounts are scripted, but that's not new news.
Okay. Yeah.
Okay. So we have this function deposit that receives payments and updates the DApp state, the contract state. Well, you already said it. The account state. Okay. And there is similar function called withdraw. It works the same. The function has one argument, how many tokens you want to withdraw. It queries current blockchain, current account state for how many tokens this account has, calculates the new amount, doesn't allow to withdraw negative amount, but it's up to you, the coder. It's up to you, the coder, to write the correct contract code. Don't blame anyone if you do the wrong thing and someone uses it. It also prevents you from taking other people's funds, so that if new amount is less than zero, effectively meaning that you're trying to take away more than you put in, then you throw another exception. And if everything is fine, then you just return a script result, both updating the account state and issuing a transfer set, meaning that you just explain to blockchain how this transaction should update the state. So the data entries should appear at the account, and transfers should go from the contract to this address that you specify. In this case, it's caller, the one who withdraws the amount.
Am I right that script result, this new data type, it just helps to avoid that problem that you said a little bit earlier, that it should be atomic to update the state and to make a transfer?
Yeah, so the thing works atomically now. If the script fails, nothing of this happens. It's either both of this write set and transfer set, or nothing.
Yeah.
Okay, maybe I can show you an example. Or no, we spoke something about predicates and the other type of script. So the idea is that okay, I'll just say something. I'll just type something, then say something, and explain what it means. Verifier tx verify false.
So it's a new annotation. There was a callable before. Now it's a verifier.
Yeah. So the thing is that this is where we put the old predicate. So in write we had predicate like sig verify, something like this. Sig verify. It requires a lot of parameters. Let's copy paste from somewhere. Oh, let's say that it could be multi-sig, right? Okay, so what this effectively means is that these functions are public interface of the account. You can call this function. I'll show example how to do it later. And the verifier function works exactly like the old predicate. See, you can just put it there. You just put the old predicate into this verifier function, and it will either allow or deny outgoing transactions. Let's say it's false. What does it mean that it's false? When it's false, it means that you cannot issue transactions from this DApp. And this makes verifier like admin function.
Yeah. So
Take a second. Think this through. When we do operations with these deposits and withdrawals, they effectively they do things similar to issuing data transactions and changing the internal state by this, and they do transfers, making outgoing transfers.
Yeah.
So, if your verifier is false, this means that you can no longer manually make outgoing transfers or change account state.
Okay.
Right? Since it's predicate that either allows or denies outgoing transactions.
Yeah.
So this makes verifier admin function. So if you want your contract to be public, and if it's a wallet, it definitely should be safe.
Immutable.
Yeah, it should be immutable. Yes, it's the correct. You can say sealed, but immutable is also.
Yeah. A good thing. So am I right that verify function is like we took the old contract and just wrapped it with a function called verify and with annotation verifier?
Yes, exactly. Yeah.
Okay. Should it always be called verify, or we can make another name?
This name could be anything.
It should be just like verify. It should has just verify annotation.
This is important. And regarding TX, in the old version we always used. Where is it? No, here. Yeah. In the old version we had to use TX always. If you do something like this, should be a compilation error. In the new version, it's actually bound through this annotation. Again, the idea is the same. We have annotation. We have bindings through annotation here, and we have bindings through annotation at verifier function. But here it binds the transaction.
There is no variable TX in global scope yet. Yeah.
No.
Okay.
Only H for height.
Okay. Only H. Okay. So I see. Cool. So
maybe let me show how this
works.
Because
we have functions and we have a lot of questions about it. How to call them, how to work with them. So it would be nice to show it, I think. So
here I have my IDE open, and I have one account imported with the seed, and I will show you the seed. But I'll create another account. Let's say that this is the app account, and another account is user account. The names doesn't matter, but just for us to understand what's happening. As we see here, what do we need to do? So the idea, let's deploy an app and make a call to a script.
So we will make a DApp, and we will call functions of that DApp, right?
Yes.
Okay.
Yes. Let's do it. Let's just leave this for now. Okay. So the first thing, we need to fund an account of the app and fund the account of user. So one can issue set script transaction and assign the app to itself, and user has enough waves to initiate the invoke script transaction. The new one, I'll show you.
Yeah, let's talk a little bit about invoke script transaction. Where is it?
Yeah, okay, well, tell me.
Where is invoke script transaction?
What is invoke script transaction? Yeah, okay. So once we deploy the app using the old set script transaction,
it's like before we deployed the usual using set script, and it's same.
Yeah, it's the same.
Yeah.
Then when someone wants to make a call to the app,
somehow interact with the app.
Somehow interact with the app. He needs to issue the new invoke script transaction and attach several necessary parameters, like which the app to call.
It's like an address?
Yes.
Okay.
Like an address. Exactly like an address. So indistinguishably like an address.
It's just address.
It's just an address. Yes. So we need to we need to specify the DApp address. We need to specify the function that we're calling, either deposit or withdraw, and arguments of the function that we are calling.
Yeah.
Okay, but before we do this, let's set up our wallets with funds. Don't look at this. Look at this. See the result. Good. I'll show you all these transactions. These are just the old transfer transactions, by the way. You can see that all we do here is we broadcast transfer with recipient of end.accounts to. So we transfer this to user.
If you're familiar with ID, I think you can understand what's going on, but I will just like try to cover what's happening here in just a few seconds. So in ID, we have different accounts. For example, here we have Waves here. It's main account with tokens, as far as I understand. We have created two new accounts, the app and user, and they do not have tokens at all. And now you're trying to send...
They virtually don't exist or virtually exist, but it's virtually the same, meaning it's the same.
Yeah. So, and you're trying to send some Waves tokens to that two accounts, and that two accounts, the first one, it should you will deploy our DApp. I mean, on DApp account, you called it DApp here. You will deploy on that account the script. The user account, the user will just interact with that DApp.
Yeah. But for now, we're just funding these two accounts.
Yeah, and there is a variable called env in the ID console.
Yeah.
Can you show it? Yeah. It's env, and it just holds all account seeds, right?
Yeah, it holds this array of accounts in this tab.
So so accounts one, for example, in this case, it's a DApp. Yes. And accounts with accounts it's an array, and with index 1 it's a DApp, and you just pass it like recipient to transfer transaction.
Yeah, you can just specify string there, but I don't want to copy paste it from here. Or,
so it's a little bit complicated, and you just make transfer transaction, call in transfer function of ID, and you just broadcast it.
For demo purposes, it's okay.
Yeah, cool.
And if you go to Waves Explorer, we will see that we have these two transactions. I believe these two transactions. Yeah. We're sending 10 waves to one account, and we are sending 10 waves to the other account.
Yeah, cool.
Let's inspect the first account that is supposed to be DApp. Where is it? It's here. Okay. Script is not yet there.
It's just like usual account with 10 waves.
Yeah, it's exactly the usual account with the address. And
with one incoming transaction with 10 waves.
Okay, now we need to do operations carefully. We switch to the app account, and we deploy this. Script there. By clicking deploy script, we sign a transaction, and then we send thing, and we have this transaction ID. If we go back to Explorer, we'll see that now this block has two transactions. Very interesting. Maybe you found the bug online. Yeah, we found the bug online. It's not.
I think it's in Explorer. So if we will go to REST API, I think we will see both of them.
We can do it the other way.
Yeah.
Let's get back to our account, and we can see that.
Here we see both transactions.
That it issued a script that it's set to itself, and the script is there. By the way, let's decompile it. Since we now have decompiling tool, we can go like this, decompile. Please don't DDoS the node. The script is there. It's not too, since it's formatted with /n, I'll fix it in a few seconds. No. H. Yeah, H. Replace all. Yeah. See, it's just like the script that we wrote. Maybe it's a bit different, but you can still get the old idea of the contract that we initially wrote.
It's readable at least.
So two functions, deposit and withdraw, with throwing and matching and returning script set. Where was I? Yeah, it's here. So two functions, deposit, withdraw, with extracting amount and returning script set. Well, there are like auxiliary things here, but it's not really a problem. You can still get the whole idea of what's happening. Okay, so the script is there now, and the data, there is no data associated with this account. But now let's make a deposit call by broadcasting invoke script transaction.
So can you
describe we'll do it slowly. So what we want is we want to broadcast invoke script transaction with the IP address of the accounts at one, of the address of this account. We call deposit function of this DApp, and with no arguments, since it doesn't require any, right? Right. Yeah. And we send 3 waves there. Let's see what happens. Yay! It's resolved. Let's observe it on a blockchain like this. Yeah, we have one new transaction, and it's of unknown type 16.
It's just like new type, and Explorer doesn't support fully.
Yeah, it doesn't support it fully yet, but you can see that it's unknown. So script, this is a known type of transaction. Unknown for Explorer, but very well known for us and hopefully for you.
The blockchain,
okay, so script is still there, and now it has data there.
Yes, can we go a little bit to the IDE for a few seconds? Can you show me the function, broadcast function, the latest one? Yeah.
This one?
Yeah. So again, we have invoke script function, which just like creates new invoke script transaction.
Yes.
Which is unknown for Explorer, but known for our blockchain.
Yes.
Yeah. And we pass there the app address. It's usual address, like for usual account.
Yes. Yes.
We get it from environment variable, like before when we make a transfer transaction. And for call object, we pass function name, arguments.
And also attach payment.
And if it's needed, we attach payment, right? Or can we just
we can try not to attach payment, but this contract, I can assure you, will not agree.
Yeah, this contract will not agree, but we can write a contract which doesn't require payment.
Yes, we'll see example of this interaction. Okay, so what we did is we invoked a deposit function and attached 3 waves.
Can you show the deposit function again,
sure.
please? Yeah. So in the end of this function, we have a write set. So we can say that deposit returns write set, which just makes one data transaction with air quotes. It's not like data transaction.
Well, the transactions do not go to blockchain. Only invoke script transaction goes to blockchain because that's enough for blockchain. It doesn't need the outputs. It only needs the what to do, but it will, all the nodes will calculate the result.
That was my next question. So all transactions like write set or when we make transfer from contract, that transactions will not go to UTX, right?
Yes.
We won't see them in UTX.
No,
we see only in the blockchain.
And we don't see them as transactions.
Yeah, we don't see them as transactions. Yeah.
Eternal under the roof, under the hood. Okay, so we did this thing. Let's see what happened. Now this account has more waves than it initially had. It had 9.99, now it has 12.99. And the data is changed by the key of the invoker of the function. We have the value of 3 and a lot of zeros, effectively meaning 3 waves. Let's just make another similar call and add some more. Now we're really into using this DApp. We send 2 more waves. Let's see. Are we 3? Data 5. Yay! It's 5. Now let's. And we're so excited about using this DApp that we even invite our friend to use it as well. So let's give this friend some money. No? Okay. For sure. Okay. Now this friend of ours also has money, and let him also deposit something like I don't know, 5. No?
Yeah, well,
Again?
there is.
Oh,
there was,
yeah.
yeah.
No. No? You didn't get our money. You didn't get our money.
No, I think you've made broadcast not to the account 1. You've made it to user maybe, because nth
it
accounts.
should be 3.
Yeah,
should be 3.
yeah.
Yeah. Account.
And there is no braces. There is 1. Nth accounts 3.
Oh,
and
yeah,
there,
yeah.
there should be
Okay,
1.
like
Yeah.
this. Okay, he supposedly has money now.
And he also.
Yeah, and he also interacts with the
No,
contract.
not he, because account was 1.
No, it's the app.
Ah, we called account.
Yeah.
Yeah.
Let's see what happened to the account state now. So yeah, it now has more money, even more money, and it's 2 records of 2 users that participate in the app
Yeah.
thingy. You and your friend, right? Okay. So let's keep everybody happy, both you and friend. For example, you want to withdraw some. You want to withdraw some of your funds. And you're like, you know what? I want to withdraw 6 waves. What does happen now? Oh no, an error. And what does it say? Not enough balance. Why does it say so? It says so because that's what withdraw function is supposed to return when you're trying to withdraw more than you own. So we tried to withdraw 6 waves, but Waves Explorer shows us that we are only obliged to 5. Okay, let's fix it. Let's not try to be the bad guys because it's impossible, because it's blockchain, right?
Yeah.
Data, yay, everything works.
And what about transfer transaction? Or can we see the balance of the first user here in the list?
The first, yeah,
So
this is
that's
the
the
balance
list.
of the first user, this is the balance of your friend.
No, I mean the balance, real balance, not
real
in the data
balance,
transactions.
okay.
Yeah.
So this is, so initially it had 10 waves,
Yeah.
now 1 is still in this
Here.
contract. Let's see if it is almost 9. Oh no, I did it
twice.
twice, yeah. So it's 10 plus 10 minus 3 transactions plus something.
Yeah.
Yeah. So it's 9 waves there. We can take the rest. No, let's take the rest.
So we should see now 1996. 19.96.
Yeah, and it's there, 19.96. Yeah.
Cool, very cool. Okay, nice. So with these functions, we introduced only one new entity. It's just like invoke script transaction.
Yes, yes.
And it's already supported in the IDE, in JavaScript library.
Yes.
So you can, I think tomorrow after activation on testnet, you can try it.
Yeah.
So everybody
please do. We'll really appreciate testing.
Yeah,
from
so
your side.
Yeah, tomorrow you can even just go to ID. You will see there this example also in id.websplatform.com. There is a huge comment with all needed functions. So you can just try to repeat it by yourself tomorrow.
Yeah, just don't forget to click.
Yeah, to change
these
accounts.
things. Yeah,
Yeah,
you can always do it from console, specifying the seed you want to make this transfers or calls or transactions from, but for testing purposes, this is actually fine.
Okay, so a few questions about payment. The first one, can we attach not only waves but any other tokens issued on? So we just can pass as, I don't know, payment, it's asset ID and amount, right?
Yes, yes.
Okay, so it's, I think
let's see how. Yeah, see when we did this. We attached this amount and no assets at all.
If it's null, it takes waves.
Yeah. It could be your favorite asset ID here. I don't have favorite asset ID.
Your favorite asset ID is waves or null, right? Okay.
Yeah, I like nulls.
Yeah. Okay, another question about payment. For example, I send a transaction. Can I add some kind of attachments to payment or no?
You can use arguments for that. Like, I mean, if your contract requires some other information other than the attached payments, just use arguments.
Oh yeah, I see. So before, some users, some developers use attachment like as an argument for smart contract.
Yeah.
Now they can just call function with needed arguments.
Like they're superheroes, these guys that use the old thing.
But they did really interesting projects using that mechanics. Yeah. So it was nice to see a lot of applications on top of the first version of Ride, let's call it so.
Yeah, just use arguments and attach payments when necessary, nothing else.
Okay, what about limitations? For example, for withdraw function, there is a contract result, as far as I remember. Can you use script result? Yeah, script result, and it returns now one write set and one transfer set.
It returns write set of one data entry and transfer set of one script transfer.
How many transfer sets, write sets it can return? What are the limitations?
Well, it could return up to 10 transfers and up until a certain amount of data, but that mostly depends on the size of data rather than the amount of key value pairs. Or maybe it's 100. Probably it's 100, yeah. So we need to somehow set the limitations here, because we couldn't just leave it as is. Limitations are needed, but what limitations to set? It wasn't clear. We decided to go with limits of data transactions.
Yeah, I see. So
no more than something, no more than something.
I see. Okay, what about sponsorship for invoke script transactions? There is a cool feature called sponsorship in the Waves blockchain. So invoke script transactions, do they support sponsorship?
Yes, they do. So you can deploy an app, you can issue a token, you can broadcast your token to people who you want to interact with your blockchain, and they can use it without having waves, without having to pay fees in waves. They'll just pay fees in your tokens, and you will effectively pay fees for them. So we had this with transfer, but now we also have this with invocation.
Okay, it's very cool. I think a lot of developers will appreciate it because it's really very cool feature. Like users should not get somehow waves. You just can send your tokens to him, just sponsor that token. It will work. So I think we will see mass adoption with this feature.
It's like last minute feature of the release, because it's reasonable enough to implement and small enough to implement as well. So not really much pain to go through another months of release cycles.
So I think we can say that with the sponsorship feature, there is -1 barrier to use the apps right now for users.
Yeah.
So okay, it's very, very nice. What about price of transactions? I think this is very, very important question. So can you cover this question as detailed as you can? Because
are you sure you want it as detailed?
Yes.
Okay. So the fee is flat, but it's again, as it's with smart tokens and smart accounts, it's flat fee per script.
Okay, what does it mean?
It means that if your contract, your invocation of script transfers a smart token, 2 or maybe 3 or maybe 4. Okay, let's use the most complex scenario. So your account is smart, smart enough to have smart tokens on it. And upon invocation, some other smart token is transferred back to you.
Gotcha. Yeah.
So what will happen? First, you pay for execution of your script. since you're smart.
Okay.
Right? Then you'll pay for the execution of the script that you're actually invoking, like the function that you invoke.
Gotcha.
And you also pass smart token. It's 3. And you get smart token back. That's 4. So your invocation triggered 4 scripts to run.
Yeah.
Right? So you will pay 1 plus 4 multiplied by 4. You pay something like 17.
0.07 or 0017.
0.
It's okay.
Yeah.
It's wavelets. We call them wavelets, right?
I need to calculate.
Okay, so you can calculate it at any time, right? Just like you just have to understand how many smart entities you interact with, right?
Yeah. So this like this versus if you do the complex scenario, it would be, and now it's 17, right?
Yeah, 0.017. Yeah.
But the default case is your account is regular, and you just work with account that works with no smart tokens. Yeah, so it would be 0.05.
Yeah,
like,
for
just like the outgoing transaction from your smart account.
Yeah, so if we just call, we pay 0.05, but in some complicated use cases we can pay more, but we can calculate it at any time. We just have to understand with how many smart entities we interact.
Yes.
Okay.
Yes. For now it's like this. We're thinking about making it simpler. Let's stick to this now. We're trying to make it simpler.
Okay. So what about like, are there any issues or I don't know, problems, limitations that you see in Write for the apps right now? Maybe something you want to improve in the future.
Yeah. Well, I don't exactly like the thing that we don't have structure of the contract defined anywhere. We just do it raw way. We just build string key for historical reasons and read it in a raw way. So here we write and we read the same variable by current key, but it's nowhere in there's no like schema for a contract. Like, I think it would be a nice idea to have schema for data of the contract.
So you want to somehow define the, I don't know,
like
keys and values,
like
possible
data structures,
data
data structure for the state. But we can define, well, we cannot technically define data structures in the right language, but again, it's not a problem. It's just let's do it.
You see how to improve the Write for the apps with
it's room for improvement, you know. Otherwise, it would be boring.
Okay. What about like further plans for Write for the apps? Do you have any plans?
Well, we're working on testing this thing, and by of course we test.
We test everything, right?
We test our block. I mean, when you write a contract, it would be nice if you could write tests for it.
Right now, you can do it in IDE using.
Using
JavaScript. There is a framework to test script sample.
I never tried this, but let's see what happens.
You never tried it using JavaScript, but I'm sure you tried it using Scala. So you can run test scripts. It's easy. It's really easy to just like you used the functions like transfer, set script, blah blah blah. You can use all these functions in your tests. So it's really easy enough to test your smart contract.
Yeah. Okay.
Against some transactions.
Yeah. This is good.
Okay.
Well, regarding, but it's just the outer thing.
Yeah. It's not about language, not about.
Yeah, but regarding the language, again, state is. Something you would like to improve on, like the description of state schema is something you would like to improve on. But well, we'll see. Maybe it will take too many resources because actually, a lot of smart contracts are very very short. Like do you know the average number
of?
How
many lines in average?
Of lines.
To be honest, no.
Like 50, 40, something like this. On average.
I mean in Waves or in other blockchains also?
In other blockchains as well. Well, now since more people start to write the apps,
there's number 44 in my mind, but I'm not sure that it's
Okay,
correct.
maybe it's the number I have in mind, yeah. But like maybe if you write just 44 numbers of code, you don't need something too
For
complex.
lines, yeah, I mean.
Yeah, maybe 44 lines of code. Maybe you're good with a bit of challenge.
I see. So let's a little bit just like compare write and write for the apps. So
Okay.
just like summarize the differences between them. First one, now you can define functions.
Yes, you can also define. By the way, you can not only define the callable functions, you can define other functions as well, like let's say func maximum. Then y else y. Good. Good. Yeah, you can define functions like this. You can use them if you want everywhere, whatever.
So you just can define function which is not callable. It is not a verifier, but you can use it in your in another functions, like in usual programming language.
Yeah, it's also definition, meaning that you can define function inside function. Let's define some other function here. Say it function called min, whatever. Maybe I can write shorter version reusing max, but that's func min. Yeah, so we can define functions inside functions, but no recursion.
For sure.
No recursion, because this will lead to unlimited computations, and this is not the thing we want if we don't want failed transactions on chain.
What about annotations? Will we have only callable and verifier, or do you have anything in mind, like maybe we can extend somehow it in the future?
Yeah, well, annotations represent functionality. It's not like they're orange and that's why they're cool.
Yeah.
They represent functionality. So regarding this, we have two things in mind. One is to build so-called default function, the function that can that will be triggered upon incoming transaction. Okay. Like, for example, you build some casino thing.
Yeah.
And I just use my wallet and I just send you money. I'm not using any DApp interface. I'm not using any.
I'm not calling any specific function.
Yeah, not calling any specific function. I'm not using any specific UI. I just work with this from wallet. I just send you a transaction and it works.
I see.
Yeah. Well, there are issues with this idea. Hopefully, we'll work them out. Another thing that would be nice to have is trigger. That's
trigger.
Yeah, it's something like, well, when someone tries...
Trigger like in usual databases, when you have, when something happens, run this code?
Well, we have unusual database anyway, so, like, when someone gets excited about blockchain and smart contracts, one of the first things they want to do is they say, now can we do something that makes automatic transfers? Like, I want to build a DApp that automatically transfers money to my landlord for the apartment that I rent.
We even have a question about it. So if I do not log into my account, for example, 90 days, can I transfer all my waves to other waves address? So this is a question from our listener right now.
Yeah.
So
that's.
I think it's a common thing.
Yeah, that's why we want to introduce something like auto trigger. So we specify a condition upon reaching some function is invoked. Like, for example, every 100 blocks or 1,000 blocks or 10,000 blocks, meaning 1 week roughly, some transaction is automatically executed. Well, this has network security concerns. Most of these problems rely on network security aspects. Like, what if there would be a lot of these auto triggers, all for one height?
Yeah.
Yeah. So yeah, we'll see.
So it's just like you're considering these features. You're thinking about it.
Yeah. Again, this thing covers a lot, but let's read it now, and with the background that we have, with these annotations now, with this state now, let's evaluate on the upcoming features more before we build them.
I see. So we have some interesting questions. Let me start with the first one. Are you gonna embed write the compiler into Waves Keeper? But I think I can answer this question because if you are interested in, we can make next dev talk with Waves Keeper developers, or with Waves Keeper product owners, or with Waves Keeper team, let's call it so. So if you're interested in Waves Keeper, we can make another video about it, and we also can cover it, because I think Ilya is mostly responsible for Node, not for Waves Keeper.
Yeah, but I might know something here.
Yeah.
So this decompiler reports through, works through REST API, and it also will also work through our JavaScript package. So this will work in Explorer. When you go to Explorer and observe a contract, I don't know, where can I find it? Yeah, it's here. Yeah, there will be a button here that just shows you the code, and not only this. Remember we talked about mutable and immutable contracts, right? So all public contracts should be marked as immutable. Well, they shouldn't be marked. They should be verifier tx verify equals false. They should have this code. Locking, what's wrong? Whatever. Locking the contract, making it sealed immutable. And when this function is there, it would be nice to have the label in Explorer saying that this contract is safe to use, meaning that it cannot be tackled with by contract issuer.
So we just can show in Explorer in the future that this contract is immutable and it's safe enough to interact with it. Mm-hmm. Okay, so you mean that this feature to decompile script, maybe it's maybe users should go to Waves Explorer to see the decompiled version of contract.
Yeah. I think what if this Waves Keeper just shows the link?
Yeah, for example. So yeah, if you're still interested in Waves Keeper, we can make another video for sure. Yeah, but at the same time, I think Waves Explorer is the more suitable place for decompiled scripts. Yeah. Okay. Second question is, if I don't log into my wallet, for example, 90 days, I already talked about this question, can I transfer all my Waves to other Waves address using write for the apps for sure?
Without logging?
Yeah.
To your account?
Yeah.
Well, yes.
How?
No, you can't. No, you can't. Because the event...
We do not have trigger functions yet.
No, not only because of this. The event of logging you into account doesn't reflect on a blockchain anywhere. Right. You just log in, nothing happens. So blockchain cannot possibly know if you logged in ever.
So client is just like a client, it just reads data. Blockchain only knows when you make a transaction. So for example, it can, in the future when we will have triggering functions, for example, it may, for example, I can imagine that use case that if you didn't make a transaction in 90 days, after that, the trigger will run and it will transfer all your Waves to another account, but not log into your client.
Yes, logging into client doesn't mean anything. It's like something from the imaginary outer space.
Okay, there's another question, like if I minted my own coin, would I be able to integrate into a smart contract? I'm not sure what does it mean precisely.
Well, yes, you can. You can make your contract work with your coin, right? Was the question? Yeah. You can accept the payments in your token. You can send your tokens. You can build your own exchange for your own token, whatever. Yeah, it's possible.
Okay, there's another question. How to validate incoming transactions to an account? Will be possible?
Good question. Looks like no.
Why?
Look, we have mass transfer transactions. So someone's doing an airdrop and sending like 100 transfers. Yeah. And then one account is sneaky. I'll set a script and won't allow you to airdrop for stock tokens, and then the other 99 people will be disappointed, right?
Yeah.
Because the transaction should either be successful or not get to blockchain at all.
Yeah, I see.
So,
Oh.
but again, we're open to discussions here. So just my personal opinion on this function.
Okay, if there's another question, I think it's not about smart contracts in this implementation, right, for the apps. So is it easier and secure to use smart contract builder to develop smart contracts?
Oh, smart contract builder.
It's just like on demo.websplatform.com.
Let's go. I like this thing. It's crazy. Crazy good, but crazy underdeveloped as well. This thing works only with data, so you cannot do any transfers of coins here. You can only build a state machine that and describe its state transitions, like add some public key rules, right? Transition rule 1, and this rule 1, and this is called.
No, it's state key.
State key, yeah, okay. Accepted, and this is called whatever, approved, approved, and different people can navigate by different paths, but it's all described in contract. Yeah, for example, you have like cargo tracking thing.
For example, yeah.
Why not? Yeah. You can say that this transition should be done by the one who requests to make package movement, and the other is done with carrier itself, and some other transition is done by other. Okay, let's see if we can open the contract.
Something went wrong. As usual on live translations.
Yeah, yeah, so we're good. Let's try again.
Right again. Click again.
Okay.
I think there was some updates. Use the ID. I'm a developer of that UI, to be honest, of this UI contract builder. So yeah, I think in near future I will fix all issues with it. So
yeah, you can issue a ticket to GitHub.
Yeah, it's open sourced, by the way. It's open sourced. It's on the GitHub.
Oh, really?
Yeah, sure. And so you can go there and you can open an issue, or you can just contribute to that. It's just like React app, so you can try to help me at least. So feel free to come to my GitHub account. Okay, there is another interesting question. What is the connection between Web3 and Write for the apps? It's hard.
How do I know? Well, when people say Web3, it's something that people tend to overuse. Like, if you go to Wikipedia, let's go to Wikipedia. Wikipedia, Web3. And now you tell me what smart contracts have to do with semantic web. Go.
I see what you're talking about, but it's just like, yeah, it's a very hard question to talk about Web3 and the kind of things, and I just asked you to...
Well, if jokes aside, for, like, why did I even open this page? Because the understanding of Web3 is like evolving and sometimes doing it dramatically in completely unexpected way. For current understanding of Web3 includes decentralized web.
Yeah.
And Write has 4 letters, and DE stands for decentralized execution, right?
So
yeah,
maybe
they're closely related, closer than you might think.
So Write, to be honest, it just helps to build decentralized applications, and I think for sure we believe at least that decentralized web is a part of Web3. Let's call it so. So Write for the app helps to build the apps. It's obvious, I think, and at the same time we try to keep it simple. We try to make it blockchain friendly, to make it developer friendly, and It also, at the same time, it's very, very, very fast. I mean, it's in terms of performance, it works very well. So that's how Write for the apps, I think, related to Web3. It just helps to build the apps, but keep working fast. I mean, the blockchain keeps working fast. It's a hard question for you, I know, as a developer, but I got this question,
Yeah,
so I had to...
come on, you're a visionary. You should answer this question.
Okay. Are there any questions, guys, I didn't cover as far as I see?
How many viewers do we still have?
Right now we have...
31?
Yeah,
Ooh.
right now. On the top it was 50, around 50. Yeah. So, there's a question here. Are you planning on sticking to Scala? I like it, but somewhere I've heard that there will be a Golang port. I think it's about the Waves node, not about smart contracts, but we can cover this question also.
We are also building an implementation of the node in Go to mainly increase the stability of network. And I would even say when you have two implementations and when you have only one implementation and something goes wrong, you might not notice it. But when you have two implementations, there is a great chance that one version is right and the other is wrong. So if you run both versions, you will see exactly the moment when this happens.
Yeah.
So if you're an exchange or you're very careful about things that happen on blockchain, you'll have a better way of understanding when something goes wrong.
I see. So there's another question. The language is developer friendly, but how do you plan to make the ecosystem developer friendly? I think this question is for me mostly, not for you, to be honest.
Okay. Let me read the questions from now.
No, I think we will have, I think, a lot of... First of all, right now we have a lot of libraries. I think the majority of them will support Write for the apps very soon. Also, we will have, we already have an IDE with Write for the apps support. We also have a console there. We work hardly on that products, and I think we will make it even better and better. Also, in the last few months, we have released few interesting and cool things like templates for Azure Marketplace, for example, because you can run your own custom blockchain in a few minutes, and I think for developers it's very interesting. We also work on all our products to make it more developer friendly, like to run it very easy, to work with it very easy. As I already said, there is testing framework for our smart contracts. We developed it in like a few weeks. So I think we will keep working on it, and we will deliver very interesting features and very interesting products in like few months. Now we have really interesting programming language with really cool features, like even like fees. I think it's very attractive for developers that we have flat fees and there is no gas at all. It's very attractive for developers. I think that we will give all needed tools to interact with that smart contract. So stay tuned, and I think you can just subscribe to our social medias to see all the updates of our products in the near future. Yeah. So let's try to find more interesting questions.
I can't see anything.
There are no questions, I think. There are no more questions about development. There are about risks or something else. So I think it's enough for one and a half hours. So
we'll keep our stream Friday friendly, I guess.
Yeah. You will still have your Friday evening free. Yeah. So if you have any questions about Write for the apps, I think the best place to go right now is our forum.
Yeah.
forum.wavesplatform.com.
Maybe we can build create a discussion
topic about
this particular
but you can
about this particular event. So
about this dev talk. So you can just ask there. Also, you can ask using Stack Overflow with tag Waves platform. So we have tag Waves platform there, and you can write your questions with that tag, and we will come and answer your question on Stack Overflow. I think you can even go to Discord. You can find the link to our Discord on our official website, wavesplatform.com.
Yeah, we have some questions.
We have some questions in our Stack Overflow also. So anyway, thank you for your time. It was a pleasure to talk with you, Ilya. Thank you very much.
Thank you now for letting me in here today.
Guys, if you're interested in this kind of live videos, just like this video, share this video, so ask your questions, and we will keep doing these videos if it's interesting for you. We will talk about developer things. I think not only about Write4D-apps, but about Waveskeeper, about all interesting technologies that we have in Waves. So stay tuned, guys, and wait for testnet activation of Write4D-apps tomorrow. It will be active tomorrow in testnet, and you will be able to try it. So thank you very much, and see you next time.
Goodbye.